Welcome students for this physics class. So we will do some questions, 5 questions from 2020 JEE question paper, and by that time Manish will join us. Okay. So I will show the question. You try yourself for about 1 or 2 minutes. Then we will look. I will show the solution and see whether if we are able to do it, it's good. இல்லைன்னா solution பார்த்து நம்ம புரிஞ்சுக்கலாம். Question number 1. I will read it or I will make it slightly bigger. Yeah. Question number 1. If we need a magnification of 375 from a compound microscope of tube length 150 millimeter and an objective of focal length 5 mm, the focal of the eyepiece should be close to அப்படின்னு கேட்டிருக்காங்க. இது மைக்ரோஸ்கோப் சம்பந்தமானது. இட் ஹஸ் காம்பவுண்ட் 375 டைம் 1 millimeter இருந்தால் 375 millimeter அது தெரியணும். அந்த டியூப் லென்த் ஆஃப் தட் மைக்ரோஸ்கோப் is 150 millimeter, அப்படின்னா 0.5 centimeter, and an objective of focal length is 5 millimeter. The focal of the eyepiece should be eyepiece of the microscope. அதனுடைய focal length எவ்வளோ இருக்கணும்னு கேட்குறாங்க. So what all is given? You have to magnify 375 times. Tube length is given. Object focal length அது ஒரு 5 mm கொடுத்துருக்காங்க. Focal length of eyepiece நம்ம கண்டுபிடிக்கணும். Try for a minute. Then we will go to the solution, no problem, but try for a minute. என்ன ஆன்சர்னு தெரியுதா? Should we go to the solution part or you are trying?
Trying, sir.
Yeah, please.
Trying, sir.
Yeah. அதுக்கு ஒரு ஃபார்முலா இருக்குன்னு நினைக்கிறேன். அந்த ஃபார்முலா மட்டும் காமிக்கிட்டுமா?
Yes, sir.
Yes, sir.
Magnification m equal to L by FO into 1 plus D by FE. FE தான் கண்டுபிடிக்கணும். இந்த ஃபார்முலா பார்த்துருக்கீங்க, எக்ஸ்போஸ் ஆகிருக்கீங்களான்னு தெரில. m equal to L by FO into 1 plus D by FE.
எஸ் சார், பார்த்துருக்கோம் சார்.
பார்த்துருக்கீங்க. அப்போ இப்போ போடுங்க. இப்போ இது தெரிஞ்சு போச்சு, அதை வச்சு போட முடியுமான்னு பாருங்கள். L by FO கரெக்டு, அப்புறம் இன்ட்டு 1 + D by FE. அதாவது ஆக்சுவலாக இப்படி இருக்கணும், கரெக்டாக போடணும்னு இப்படி இருக்கணும். ஆ இல்லைன்னா எப்படின்னா எஃப்ஓக்கு ஐ மீன் டினாமினேட்டில் 1+d/fe இருக்கிற மாதிரி இருக்கும். அப்படி இல்லை, L/FO இன்ட்டு 1+d/fe. இதில் m கொடுத்துருக்காங்க 375, எல் வந்து 150 மில்லிமீட்டர், எஃப்ஓ கொடுத்துருக்காங்க, எஃப்பி கண்டுபிடிக்கணும்.
சார் டி ஓட வேல்யூ என்ன சார்?
டிஎன்ஏ என்ன எனக்கு தெரியாது, நீங்கள் தான் சொல்லணும்.
25.
25 கரெக்ட், 25 சென்டிமீட்டர். டி இஸ் 25 சென்டிமீட்டர். ஆமாம். இதில் கொடுக்கல, ஆனால் டி 25 சென்டிமீட்டர் உங்களுக்கு தெரியணும் மாட்டிருக்குது. ஐ டோன்ட் நோ ஹவு யூ டிரைவ் டி, ஐ டோ நாட் நோ. எப்படி 25 கண்டுபிடிச்சிங்கன்னா? யாரோ 25 சொன்னவர்?
சார் நியர் பாயிண்ட் ஃபோக்கஸ்.
எது?
நியர் பாயிண்ட் ஃபோக்கஸிங் சார்.
நியர் பாயிண்ட் ஃபோக்கஸிங். ஓ, அந்த 5ஓட ஸ்கொயரா அது? இல்லை தெரில, அது என்னமோ. ஓகே, டி = 25 இஸ் கரெக்ட். அவர் சொன்னது கரெக்ட். இப்போ போடுங்க, டி = 25 போடுங்க, எவ்வளோ வருதுன்னு பார்க்கலாம். என்ன ஆன்சர் வருது?
சார் 21.7.
21.7 mm இஸ் த ரைட் ஆன்சர். அதில் ஆப்ஷனில் பார்த்தீங்கன்னா 22 mm இருக்குது. அதுதான் பாருங்க, இந்த
ஆப்ஷன்
ஃபோக்கல்
1 சார்.
should be close to தான் கேட்டிருக்காங்க. அப்போ 22 mm இஸ் த ரைட் ஆன்சர். இந்த ஃபார்முலா எல்லாருக்கும் தெரியுதா? 12th குழந்தைகளுக்கு எல்லாருக்கும் தெரியுதான்னு பாருங்கள். 12th 11th எந்த போர்ஷன் தெரியல.
எஸ் சார், தெரியுதுங்க சார்.
அப்புறம் ஏன் அது உடனே உங்களுக்கு ஸ்ட்ரைக் ஆகலை முதல் 2 மினிட்ஸில்? அதான் உங்களுக்கு இந்த பிரச்சனையே என்னென்னா, யூ டோன்ட் நோ ஹவு டு அப்ளை. நாலேஜ் இருக்குது, கான்செப்டும் தெரியுது, எப்போ எங்கே அப்ளை பண்ணணும்னு தெரிய மாட்டேங்குது. அது பிகாஸ் உங்கள் எக்ஸாம் பேட்டர்ன் வந்து அப்படி வச்சுட்டாங்க. வேறாஸ் இன் சம் அதர்ஸ் போர்டில் அந்த எக்ஸாம் பேட்டர்ன் ஸ்லைட்லி டிஃப்ரெண்ட். அங்கே அப்ளை பண்ணியே ஆகும். அது எப்படி அப்ளை பண்ணுறது, அந்த எக்ஸாம் அந்த டெஸ்டெல்லாம் அது அப்படி பண்ணாங்கன்னா அது வரும். இல்லைன்னா நீங்கள் அதுக்காக தான் ஒரு இந்த மாதிரி கோச்சிங் இன்ஸ்டியூட்டில் அந்த அப்ரோச் வரும். திஸ் இஸ் வாட் வி கால் ஆஸ் நம்ம இது எம்சிக்யூ அப்ரோச் ஆர் என்ட்ரன்ஸ் அப்ரோச். இப்படி இருக்கணும். போர்டு அப்ரோச் வேறு மாதிரி இருக்கும். இதை தான் அடிக்கடி சொல்கிறேன். நாலேஜ் இருக்குது, கான்செப்ட்டு தெரியும், ஆனால் மார்க் வரல இந்த என்ட்ரன்ஸில். அது ரொம்ப வேதனையாக இருக்கும் எனக்கு. ஏன்னா நாலேஜ் இல்லை இந்த குழந்தைக்கு அப்படின்னா பரவாயில்ல, ஐ வில் நாட் பாதர். பட் யூ சே யூ நோ திஸ் ஈக்குவேஷன், பட் வி ஆர் நாட் ஏபிள் டு சால்வ் த ப்ராப்ளம். வாட் டு ஐ டூ? இப்போ உங்களுக்கு உங்கள் பிரச்சனையே தெரியும். பிரச்சனை தெரிஞ்சாவே பாதி சால்வ் பண்ண மாதிரி. அது எப்படி என்ன அப்ரோச் எடுக்கணும்னு நீங்கள் பாருங்கள். ஓகே, லெட்ஸ் கோ. கேன் வி கோ டு கொஸ்டின் நம்பர் 2?
Yes, sir.
ஓகே, கொஸ்டின் நம்பர் 2 போகலாம். பெருசு பண்ணுறேன். The radius of gyration of a uniform rod length L about an axis passing through a point L by 4 away from the center of the rod. The perpendicular to it is. இப்போ என்ன கண்டுபிடிக்கணும்னு பாருங்க. முதல்ல என்னென்ன கொடுத்துருக்காங்க, என்ன கண்டுபிடிக்கணும்னு பாருங்க. இதில் இந்த மூமெண்ட் ஆஃப் இனர்ஷியா அந்த கான்செப்ட் யூஸ் ஆகுமா? To solve this question, should we make use of the concept called moment of inertia? I think you should be able to make use of the concept called moment of inertia. ஸோ அந்த ஒரு டிப் ஐ கிவ், ஒரு டிப்ஸ் கொடுத்துருக்கேன். ஏதாவது ஃபார்முலா தெரியுதா? என்ன ஃபார்முலா யூஸ் பண்ணணும்? மொமெண்ட் ஆஃப் இனர்ஷியா ரிலேட் பண்ணி ஒரு ஃபார்முலா பண்ணணும்னு நினைக்கிறேன். என்னன்றதை கண்டுபிடிங்க பார்க்கலாம். So let me go to the solution. பார்க்கலாம். Moment of inertia of the rod passing through a point away from the center of the rod is equal to, என்னமா கொடுத்துருக்காங்க ஒரு ஃபார்முலா, I equal to IG LG, அது IG நினைக்கிறேன், IG plus ML ஸ்கொயர். இந்த ஃபார்முலா வச்சு தான் இது பண்ணணும் மாட்டிருக்கு. கண்டுபிடிங்க, இதை வச்சு எதை பண்ண முடியுமான்னு பாருங்கள். அதே மாதிரி மூமெண்ட் ஆஃப் இனர்ஷியா ஐ ஈக்குவல் டு எம்கே ஸ்கொயர். ரெண்டு ஃபார்முலா. எம்கே ஸ்கொயர் என்பது கே இஸ் ரேடியஸ் ஆஃப் ஜைரேஷன். கே என்றது ரேடியஸ் ஆஃப் ஜைரேஷன். அதை தான் கண்டுபிடிக்கணும் நம்ம. இப்போ அதான் கேட்டிருக்கேன், கே தான் கண்டுபிடிக்கணும். ஸோ இந்த ரெண்டு ஃபார்முலா தெரியணும் உங்களுக்கு. So this question is related to moment of inertia. Moment of inertiaவுக்கு ரெண்டு ஃபார்முலா இருக்கிற மாதிரி தெரியுது. அந்த ஒரு ஃபார்முலாவில் ரேடியஸ் ஆஃப் ஜைரேஷன் இஸ் இன்க்ளூடட். அனதர் ஃபார்முலாவில் அந்த லென்த்து அதெல்லாம் ஏதோ வருது. ஸோ அதை வச்சு நீங்கள் கண்டுபிடிச்சிருக்காங்க. So the answer is √7/48 into L. அதை அங்கே எழுத முடியாதுங்கிறனால L into square root of 7/48 எழுதியிருக்கேன். Square root of 7/48 into L. That is the answer. வருதான்னு பாருங்கள். நீங்கள் அது கால்குலேட் பண்ணி அது கரெக்டாக வருதான்னு பாருங்கள். ஃபர்ஸ்ட் ஆஃப் ஆல் ஒரு கொஸ்டினை படித்த உடனே இது எந்த கான்செப்டை ரிலேட்டடாக வந்திருக்குன்னு நம்ம தெரிஞ்சுக்கணும். இதில் இந்த கொஸ்டினில் மொமெண்ட் ஆஃப் இனர்ஷியாங்கிற ஒரு வார்த்தையே கொடுக்கல. பட் அந்த கான்செப்டை வச்சு தான் இது நம்ம சால்வ் பண்ண முடியும்னு இதில் ஆன்சர் சொல்யூஷனில் கொடுத்துருக்காங்க. புரியுதா? நான் எழுதியிருக்கிறது இங்கே புரியுதா? ஏன்னா அந்த புக்கில் இருக்கிற அப்படியே நான் காப்பி பண்ணி எழுதியிருக்கேன். அந்த அந்த ஐ ஹேவ் ஒன் புக் அதை வச்சு அப்படியே காப்பி பண்ணி எழுதியிருக்கேன். Anyway, if you don't understand, you again go through your book, textbook, or any guide or whatever, and learn the importance or the meaning of each of these. What is the meaning of K? What is the meaning of I, L? என்ன ரிலேஷன், என்னென்ன ஃபார்முலா, how do we use it அப்படிங்கிறத நீங்கள் தெரிஞ்சுக்கணும். You may know, sometimes you may know formula, you don't know how to use it. Sometimes you don't know formula at all. அப்படி இருக்கும். ஸோ அப்போ அந்த புது ஃபார்முலா வந்து அதை பழகிக்கு. Should we go to next third question? போலாமா third question? Okay, you are giving answer in this, you know. Third question போலாம். படிங்க யாரோ ஒருத்தர். Can anybody read this question?
A Carnot engine operates between two reservoirs of temperature 900 Kelvin and 300 Kelvin. The engine performs 1200 joule of work per cycle. The heat energy in joule delivered by the engine to the low temperature reservoir in a cycle is
கேள்வியை மேபி 2-3 தடவை படிங்க. எங்கே இந்த கேமட் என்ஜின் படிச்சிங்க, எங்கே they are relating, you know, two reservoirs of different temperatures, what is the energy transferred, delivered from higher temperature to lower temperature, அதுக்கு என்ன ஃபார்முலா தான் இருக்குதா அப்படியெல்லாம் பாருங்கள். இதுக்கு என்ன ஃபார்முலா யூஸ் பண்ணணும்னு ஏதாவது தெரியுமா?
Sir,
சொல்லுங்க.
1 minus TL by TH.
கரெக்ட். சொல்லுங்க சொல்லுங்க. 1
Sir, அந்த
minus
formula யூஸ் பண்ணு.
சொல்லுங்க.
TL by TH.
மறுபடியும் சொல்லுங்க.
Sir, 1 minus TL by TH.
TL divided by TL divided by TH. TH
sir.
இது bracket க்ளோஸ் பண்ணிக்கலாம். ஈக்குவல் டு வாட்?
Sir, 1 second, sir.
1 second. ஓகே. மற்றவங்க சொல்லுங்க. என்ன ஃபார்முலாவே தெரியலன்னு ஒன்றும் பண்ண முடியாது. சிஎஸ் அது பாதி ஃபார்முலா சொல்லிட்டாங்க அவங்க. இந்த எங்கேயாவது பார்த்த மாதிரி தெரியுதா உங்களுக்கு? TL means temperature of the lower reservoir, lower temperature reservoir, temperature of the higher temperature reservoir. அதுதான் மீனிங். சொல்லுமா, ஃபார்முலா கம்ப்ளீட் பண்ணுங்க. பாதி சொல்லி விட்டீங்க. யாருக்குமே ஃபார்முலா தெரிய மாட்டேங்குதா? அப்போ இந்த இந்த கான்செப்டே புரியலன்னு அர்த்தம். சப்ஜெக்டே அந்த சாப்டரே நீங்கள் புரிஞ்சுக்கலன்னு அர்த்தம். அதுதான் மீனிங். ஏன்னா பாதி ஃபார்முலா கொடுத்துருக்காங்க, இன்னொரு ஃபார்முலா தான் கேட்குறேன். அப்புறம் எப்படி அப்ளை பண்ணுறதெல்லாம் அப்புறம் பார்க்கலாம். பை Q1 கரெக்டாமா?
TL by
ஆ
yes sir. Sir QH.
QH ஓகே. ஹெச்சா ஒன்றும் அது வேறு ஹெச் போடுங்க. இதை யூஸ் பண்ணி போட்டு பாருங்கள். ஐ திங்க் ஷீ இஸ் கரெக்டுன்னு நினைக்கிறேன். ஆமாம், ஷீ இஸ் கரெக்ட். ஃபார்முலா இஸ் கரெக்ட். ஐ டோன்ட் நோ வாட் இஸ் த மீனிங் ஆஃப் திஸ் ஃபார்முலா, எனக்கு தெரியாது. பட் ஃபார்முலா இஸ் கரெக்ட். 1 minus TL divided by TH equal to W by QH. என்ன கண்டுபிடிக்கணும் அப்படி பாருங்க. இப்போ 1 by 1 பார்க்கலாம். TL எவ்வளோ? TL
900 sir.
TL 900 300? TL 900 300?
Sir 300 sir.
அப்பாடா, உங்களோட பெரிய ராவடியாக இருக்குது. இது 900. சும்மா ஃபார்முலா தெரிஞ்சிட்டிங்க, அது என்ன எதுக்கு, டிஹெச்னு என்ன டிஎல்னு என்ன அதெல்லாம் தெரியாமே தெரிஞ்சிட்டிங்களோ. ஓகே, TL ஈக்குவல் டு 300, TH ஈக்குவல் 900. ஓகே, வேறு என்ன கொடுத்துருக்காங்க? W கொடுத்துருக்காங்களா?
Yes sir.
வாட் இஸ் தட்?
1200 joules sir.
ஓகே, இதுலேருந்து என்ன கண்டுபிடிக்கலாம்? QH கண்டுபிடிக்கலாமா?
QH கண்டுபிடிக்கலாம் sir.
எவ்வளோ? டக்குன்னு கண்டுபிடிச்சு சொல்லுங்க.
போட்டுட்டு சொல்றீங்க சார்.
அது எவ்வளோ நேரம் ஆகுது போட்டுருக்குது? மற்றவங்களாம் என்ன பண்ணுறாங்கன்னே தெரில. Find out QH and tell me. Formula is given and each one the numbers also given.
Sir 900.
QH 900 நல்லா பாருங்க. அவர் 900 சொல்கிறாரு. ஆன்சர் 900 இல்லை QH 900?
சார் 800 ஜூல் சார்.
இல்லை ஆன்சரா?
எஸ் சார்.
ஆன்சர் 800 இஸ் ராங். நீங்கள் முதல்ல QH கண்டுபிடிங்கப்பா. சும்மா வாயில் வந்ததெல்லாம் சொல்லாதீங்க. QH கண்டுபிடிங்க. எவ்வளோ வருது?
1800.
அப்பாடா. இப்போ என்ன கேட்டிருக்காங்க? What is asked? QH is equal to 1800. இந்த Wங்கிறது என்ன? The heat energy delivered by the engine to the lower temperature reservoir is equal to QH minus W. That's the answer. QH minus W எவ்வளோ?
600.
That's the answer.
Sir.
உங்களுக்கு ஐ டோன்ட் நோ எங்கே நீங்கள் ஸ்ட்ரக் ஆகுறீங்கன்னு எனக்கு தான் புரியல. ஐ எம் நாட் ஏபிள் டு இந்த சாப்டர் நீங்கள் தரவாக இருந்தீங்கன்னா போடுறதுல பிரச்சனை வரலாம். பட் அந்த கான்செப்ட் தரவாக இருக்கணும் இல்லையா? வாட் வி மீன் பை டிஎல், டிஹெச், டபிள்யூ, QH, QL எல்லாம் தெளிவாக இருந்தால் தானே நீங்கள் போட முடியும். அப்படியே ஃபார்முலா கிடைச்சாலுமே போடுறது கஷ்டமாக தெரியுதே உங்களுக்கு. ஐ டோன்ட் நோ. ஐ எம் நாட் ஏபிள் டு அண்டர்ஸ்டாண்ட் வை வாட் இஸ் யுவர் ப்ராப்ளம். இந்த ப்ராப்ளமே எனக்கு என்னன்னு புரிய மாட்டேங்குது. எனிவே ஓகே லெட்ஸ் கோ டு கொஸ்டின் நம்பர் 3. என்ன ஆன்சர் கொடுத்துருக்காங்க பார்க்கலாம். பாருங்கள். Manish has come. Welcome, Manish. Give me 1 minute. We are looking at some 4 questions. 3 we have completed. We will complete one more.
Yes, uncle. Yes. Yeah. Sorry about today's children. I was late.
Okay.
I was traveling, huh?
Question
Yeah.
4 பாருங்க easy. இந்த question 4 easy. போடுங்க பார்க்கலாம் குழந்தைகளா. இதோட முடிச்சுக்கலாம். Question 4 ஓட முடிச்சுக்கலாம். I think I have got 5 questions, but we will have only question 4 ஓட முடிச்சுக்கலாம். Somebody can read this question 4. This is JE 2020 question.
Can I read it? Sir?
Yeah.
In a building,
Yeah.
In a building there are 15 bulbs of 45 watts, 15 bulbs of 100 watts, 15 small fans of 10 watts, and 2 heaters of 1 kilowatts. The voltage of electrical main is 220 volts. The minimum fuse capacity rated value of the building will be.
எப்படி போடணும் மட்டும் சொல்லுங்க முதல்ல. அப்புறம் நம்ம எப்படி போட then we will calculate. See, they wanted to know the maximum ampere current. Okay. Current, they wanted to know the current. They have given the voltage. So they have given that power consumption. அதுவும் கொடுத்துருக்காங்க. அதை நீங்கள் கண்டுபிடிக்கணும். How much is power consumed கண்டுபிடிக்கணும். அது எப்படி கண்டுபிடிக்கிறது? ஒரு பல்பு 15ன்னா 45 வாட்ஸ்ன்னா 15 பல்பு எவ்வளோ? 15 + 45 இல்லை 15 × 45?
675, sir.
அதெல்லாம் 15 × 45. ஓகே, யூ கேன் ஈவன் டெல் இன் திஸ் ஃபார்ம் ஆல்சோ. நீங்கள் கால்குலேட் பண்ணியே சொல்லணுங்கிற அவசியம் இல்லை. சரி, அதே மாதிரி எல்லாரோட பவர் கூட்டி ஆட் பண்ணி அதை 220 டிவைட் பண்ணால் ஆன்சர் வரும்னு நினைக்கிறேன். பாருங்கள். என்ன ஆன்சர் வருது உங்களுக்கு? ஸோ 15 × 45 அதான் பவர்.
675 சார். 675.
சரி, அதான் மொத்தம் அதெல்லாம் கூட்டிட்டு டிவைட் பை 220. ஹவு மச் யூ ஆர் கெட்டிங்? குவிக். $15 × 45 plus 15 × 100 plus 15 small fans of 10 watt, 15 × 10 plus 2 × 1000 போடுங்க எவ்வளோ வருதுன்னு பாருங்க. That is the total power. Divide by 220. Then that will give you the current.
20 watt. 20 ampere. 20 ampere.
20 ampere is the right answer. அதான் பாருங்க, அதனுடைய நெட் பவர் அப்படி ஆட் பண்ணி P/P 19.6 வருது, அப்ராக்சிமேட் 20 ampere. Yeah, go ahead with the Manish. That's all my this one. I'll stop sharing.
comparative point of view. So I have pulled out previous year questions for today. Sir Pandamadri Eda. So I have also kept questions so that because it is the exam time. So and even the exams are also nearing, it will be useful. So that is why I have brought in questions today. So we will be doing questions. Once the concepts are done, we are going to see each and every formula, different types of formula for the comparative approach, and then we will start solving the questions. All right. So here we go. We'll start off with each one of them, starting with the first concept, basic representation. We are going to see. So how do we represent an alternating current or an alternating voltage? Can anybody tell me the general representation we have seen in the last case? How do we represent an alternating current? I. You can say I is equal to I naught sine of omega t. Okay, the general representation where I is basically your instantaneous current. I naught is nothing but peak current, okay, or maximum current. Omega is angular frequency and T is instantaneous time. So this is general representation. Same way, alternating voltage can be represented as V is equal to V naught sine of omega t. So these are general representations of current and voltage, where I naught and V naught are peak currents and peak voltages. So these are typically peak values. Okay, so these are peak values. And your omega, what is omega? Omega is your angular frequency. Okay. Angular frequency. Okay, so omega is angular frequency. The units are in radians per second. So that is the unit. And how do we represent omega in terms of time period? All of you might be knowing. We can write omega is equal to 2 pi upon t, where t is your time period. So this is one relationship which we generally use. So these are the basic representations of current and voltage. Now without delay, moving on to the next one. Third one, you will have to know what is the mean and average values. First, we will see the mean values or average values. So mean values of current, I mean, or you can also write it as I average. Okay, is nothing but 2 by pi times I naught. Okay, where 2 by pi gives you a specific value. Okay, so generally it is 2 by pi times I naught, where I naught is nothing but your peak value of current. Okay, this 2 by pi is found out to be 0.63. It goes like that. Okay, I remember two values, so I'm writing two values. So 0.63 times I naught. Okay, same way we can write voltage, mean voltage value, or the average voltage value, V average. Same way, it can be written as 2 upon pi times V naught, where V naught is peak voltage. So can be written as 0.63 V naught. General representations of voltage and current average or mean values. So this is the relationship. Same way, next we have down the line root mean squared values, which is also called as RMS values. Okay, which are called root mean squared values. So it can be written as IRMS and VRMS. So same way, we will write IRMS is equal to I naught upon root 2. This is the relationship, which is 0.707. Okay, this value I know 1 upon root 2 is nothing but 1.707 times I naught. Same way, VRMS. So VRMS will be written as V naught upon root, which is 0.707 V naught. So like this, you have the RMS values of both current as well as voltage. I hope it is clear so far. So we have seen what are the different ways of expressing current and voltage in terms of general expression, in terms of mean or average values we have seen, and next we have seen in terms of RMS values. Okay, this is all we have seen. Okay, and then moving on to the next one. So now we will see what are the different types of circuits. Okay, first we will start off with the AC circuit, which is consisting of only a resistor. Okay, so AC resistor circuit. Okay, what do you mean by AC resistor circuit? When you connect a resistor to an AC source, so this is an AC source, you can see at the bottom, and this is basically a resistor with resistance R. So your AC source is nothing but your V naught, V is equal to V naught sine omega t. That is the voltage of your AC source. Okay. Now, whenever you have a value like this, whenever you have a circuit like this, what are the different components that we can find? So we will first need to write down what is the expression for current. Very important. From Ohm's law, we all know current is the ratio of voltage and resistance. So V upon R. So substitute here, V is nothing but V naught sine omega t. Okay, upon R. But we all know that V naught by R can also be written as I naught, so which is very similar to I naught sine omega t. Is it clear, children? Very simple. So this is how we express the current in an AC resistor circuit. From using Ohm's law, we can derive the relationship. Simple. And here, very important, it needs to be noted that for a AC resistor circuit, your both current and voltage, they are in same phase. Okay? So that is an important point to be noted. Current and voltage are in phase. What do you mean when they are in phase? That means there is no difference of angle between them. The vectors overlap over each other, so that such that the angle is zero. Phase difference is zero. That is what it means. Both the current and voltages are in phase. Okay. So that is for the AC resistor circuit. Now moving on to the next circuit. After this, we have the sixth one. We'll see the next one, which is basically your AC inductive circuit. So we'll see AC inductive circuit. What is an AC inductive circuit? Inductive means what? Okay, inductive means basically it is an inductor. Okay, inductor is also an element, an electrical component which looks like this. It looks like a spring, like this. It is having an inductance of L. Okay, so that is what is an AC inductive circuit. So we will connect the circuit. This time, instead of a resistor, we are going to connect an inductor like this, again to an AC source. Simple. So this is your AC inductive circuit with inductance L. And again, voltage is nothing but V is equal to V naught sine omega t. Okay. Now, inductance. Inductance is basically represented using the letter N, L, capital L, L as in London, and the unit is in Henry. Okay, the SI unit of inductance is Henry, which is represented using capital H. Okay, that is the unit of inductance. So now whenever you have an AC inductive circuit, now again, we are going to represent the current. Okay, so voltage is V is equal to V naught sine omega t, no doubt. But when you write current, I is equal to, we don't write sine omega t. Here it is omega t minus pi by 2. Very important. We write it as I is equal to I naught sine omega t minus pi by 2. So what is this minus pi by 2? There is an additional term. It means that there is a phase difference. So the phase is not same for both current as well as voltage. Okay. Because when you try to find out what is the current, so therefore for an inductor, it is a differential function of current. That is the reason there is a phase difference or there is a phase angle that is coming into picture. So I is equal to I naught sine omega t minus pi by 2. So this pi by 2 is basically your phase angle. Okay, it differs by a phase angle of pi by 2. Now, whether it lags or whether it leads is based on the sign convention that is being used. So here you can see it is minus pi by 2. So therefore, you can see that the current is going to lag behind the voltage. So whenever you have an expression like this, you have to understand that whenever there is a negative sign convention, okay, the negative sign indicates current lags voltage. Okay, the current lags voltage by an angle of 90 degrees. That is, in radians it's pi by 2, in degrees it is 90. Okay, so this is the expression. So these are important aspects that you should know. Same way, here how do you find out the value of I naught? Okay, what is I naught value? That is peak value of current. Okay, you know that from Ohm's law, I is equal to V upon R, no doubt. So it is V naught upon, instead of R, here we don't have a resistor, we have an inductor. So we would represent in terms of the inductive reactance, which is called XL. Okay, so XL is nothing but inductive reactance. Unlike resistance, here we use inductive reactance. Now, inductive reactance has got a formula. Okay, anybody knows the formula for inductive reactance by any chance? I know it is a new concept. Okay, so here inductive reactance has got a relationship. So XL is equal to omega L. That is the relation. All right, where omega is angular frequency and L is nothing but the inductance. Okay, so this is the formula for inductive reactance. The unit, again the SI unit here, children, is ohms. Okay, it is same as the resistance itself. Okay, so these are the relations that you'll have to keep in mind as far as AC inductive circuit is concerned. All right, so with that, we move to the next one. We'll have a quick recap for AC inductive circuit. Here you have an inductor instead of a resistor connected to an AC source, having source voltage as V is equal to V naught sine omega t. Now writing the expression for current, there is a small difference. We write it as I is equal to I naught sine omega t minus pi by 2. Here minus pi by 2 would indicate that current is lagging the voltage by an angle of 90. So therefore, you can see there exists a phase difference between current and voltage. Now, I naught can be expressed as the ratio of voltage and reactance. So as from Ohm's law, so therefore you substitute the value of reactance as omega L. We finally can write I naught is equal to V naught upon omega L. So you get, ultimately you get this relation. So this is all about AC inductive circuits. Okay. So next we are moving on to the next part. Okay, the number is 7. Okay. Going to the 7th concept. Next we have AC capacitive circuit. AC capacitive circuit. Now what do you mean by capacitive circuit? What is a capacitor? Alright, capacitive circuit means you have a capacitor. The capacitor is again represented using just a parallel line. You can see that 2 parallel lines are there. So we represent it using 2 parallel lines for a capacitor. One is a positive plate and the other is going to be a negative. All right. So that's how we represent it. We have learned in the second chapter electrostatic potential and capacitance. So now with this information we are moving ahead. So the circuit for this would look like this. You have a capacitor connected to an AC source, which makes your AC capacitive circuit. Capacitance value we will take it as C. Now here the unit of capacitance is basically farad. Okay, SI unit of capacitance is farad. F-A-R-A-D, farad, which is represented as capital F. Okay, that is the unit. And again, your AC source, we will write it as V is equal to V naught sine omega t. That is always same. There is no change in the AC source. Okay, this is how your AC capacitive circuit would look like. Now for this, when you write the expression for current, now here it is pretty different. Unlike an inductor circuit or an inductive circuit, here we will write I is equal to I naught sine omega t plus pi by 2. Okay, sine omega t plus pi by 2. You can see the difference. There we had minus pi by 2 and here we are having plus pi by 2, which ultimately means that current is leading voltage by an angle of 90 degrees. This is what the positive sign would indicate here. Okay, so in simple terms, we can write current leads voltage by 90 degrees. That's it. Okay, so this is all about your AC capacitive circuit. Coming down to the expressions. Now again, here you can write down the value of I naught. Okay, so I naught can be written as V naught. Okay, upon XC. Here XC is called capacitive reactance. Very important. Instead of inductive reactance, we have here capacitive reactance. That's it. That's the only difference. So we call this term as capacitive reactance. Okay. So again, capacitive reactance has got a formula. Okay. So we can write capacitive reactance as 1 upon omega c. This is the relation for capacitive reactance. When you go and substitute it in this formula, what happens? Ultimately, you can get the relation for current, peak current I naught as V naught times omega c. So you will write it as V naught times omega c. That's it. So that is how we can express the peak current and peak voltage in case of NEC capacitive circuit. Okay, I hope it's clear so far. So like this, we can represent the different parameters of current and voltage for AC resistive circuit, for AC inductive circuit, and for AC capacitive circuit. So we can do it like this in for three different circuits. Okay, we have written relations for each one of them, and we have discussed all these things so far. Now we are going to go a step ahead, and we are going to see combination of circuits. Okay, that is either we can have resistance and capacitor together, or we will have capacitor and inductor together, or inductor and capacitor together, or all three together. So like this, we have different combinations. Now we have seen A, B, and C separately. What I'm saying, you can have AB together, you can have BC together, or you can have CA together. So these are next, higher versions of alternating current circuits. Okay, so we have now covered the basic circuits. So now we are moving ahead with the next circuit, the next possible circuits. So for our exam for the competitive point of view, so combination of circuits, we have series LCR circuit. So let me just write it here. AC series LCR circuit. AC series LCR circuit. Okay, so this is what we will be seeing next. Okay, so we'll see it. So what is LCR circuit? What does LCR mean? Okay, so L stands for inductor, C stands for capacitor, and R stands for resistor. Okay, so when you have all these three components connected to an AC source, that's what makes up an AC series LCR circuit. So we'll see each one of them. So first inductor, then capacitor, then resistor. Okay, so these are the three circuits. So this is inductor, this is capacitor, this is resistor. Okay, so these are the three different things. All right, so we have three different components which are connected together. Yeah, just give me a minute, children. I'm coming back. Yes, children, I'm back. So I hope I'm audible to everybody. Yeah. Okay. So here you have three elements. That is, you have your inductor, you have your capacitor, and the resistor, which are connected to a AC source. So this is how it is. This is how your series LCR circuit would look like. You have a resistor, you have a capacitor, and you have an inductor from right to left. This is how they are connected. When they are connected like this, now we try to find out what is the relationship between current and between voltage as far as the phase angle is concerned, as well as your peak currents and peak voltages are also concerned. So we will see each one of them. Okay. Here again your voltage value, that is your AC voltage source, is given by V is equal to V naught sine omega t. So as we know, general expression of alternating voltage. Obviously this is there. The same way, when you write the expression for current, it is pretty different. You can't simply write I is equal to I naught sine omega t. Again, because you have three different sources here, so we will write I is equal to I naught sine omega t minus pi. So we are trying to generalize here based on the elements that we have. So here phi is nothing but your phase angle. Okay, so this is your phase angle. Okay, I naught is peak value and omega is angular frequency, which you guys are aware of. Okay, now we can write expression for peak currents, that is your I naught, as I naught is equal to, from Ohm's law, it is V naught upon some value, where we will call that value as impedance. Here we call that as impedance. Now, what is impedance? Impedance is nothing but the total effective resistance offered by your inductor, capacitor, and resistor together. So that is called as the impedance. Let me just write it here. This term Z is called as impedance. Impedance is nothing but the total effective resistance offered by L, C, and R. That is your inductor, capacitor, and resistance, all three of them together. Okay, that is why we call that impedance. All right. So now we are moving on. Now, so Z is equal to, so this impedance Z or Z is equal to under root of R square plus XL minus XC the whole square. Okay, so this is the formula for the impedance children. That is your resistance, your capacitor, and inductor, all three of them connected together in series for a series LCR circuit. This is the value of impedance that can be calculated. You calculate using this particular relationship. Now here it's very important, as you guys are aware, your XL and XC are having the formulas. This XL is nothing but omega L, and XC, capacitor reactance, is 1 upon omega C. Not to forget, these are the relations. Okay, in case you will have to find them out individually, yes, you will find them out, and then you will substitute here to find out the impedance of this circuit. So this is how you will have to do it. It will usually be a two-stage process. All right, so this is impedance of your series LCR circuit, which is nothing but the total effective resistance of the circuit. Okay. Now coming to the phase angle phi. How to evaluate phi for this series LCR circuit? So phi is given by the relation tan inverse. Okay, it is given by the relation tan inverse of XL minus XC upon R. This is basically the formula for the phase angle for a series LCR circuit. Okay, that is the phase difference. Usually we call it as phase difference or phase angle. Okay, so this is how you find out. This is an important aspect, a formula to be kept in mind. Now, based on this, we have something called as an impedance triangle, which comes next. So we can represent these values, okay, using a triangle called as impedance triangle. So what is meant by the impedance triangle? So let's try to understand this. So impedance triangle is a right angle triangle wherein whose base would represent the resistance R. So I'm drawing a right angle triangle. its base is going to represent the resistance R. This is your right angle. Let me name this triangle first. So let me call it A, B, and C. AB is the base and BC is nothing but the height. So the base is represented using the resistance. The hypotenuse is represented using impedance, which is Z or Z. And the height BC is represented using XL minus XC. So that is your base. That is the height. Okay. So like this, we have the impedance triangle. So when you have the impedance triangle like this, not to mention the angle phi. So angle phi is here. Angle CAB is angle phi. So when you apply tan ratio, which is opposite to adjacent, so you understand that tan phi is going to be XL minus XC upon R. That is what I have written on the top. Okay. So using impedance triangle, it is very easy for us to get the relationship for the phase angle phi. Okay, so it's an easier way to understand, to correlate the different parameters in an AC LCR circuit, which are in series. Okay, so this is the impedance triangle. All right. Now there are different conditions wherein you will have to keep in mind. Now, what are the different conditions? Let us see each one of them in detail. Okay, so the conditions are, if say XL is greater than XC, that is, your inductive reactance is greater than capacitive reactance, you need to understand that tan phi value is positive. So tan phi is positive, right? If it is going to be greater, obvious. So when you subtract them, you will have a value which is going to be positive. Okay. So when tan phi is positive, so therefore phi value is also going to be positive. So in this case, what will happen to current and voltage? So here current will lag behind voltage. So we say current lags voltage by the phase angle phi. Same way, if XL is going to be less than XC, you need to understand that here tan phi is negative. Okay, it will be negative, and in this case, current, you will say it leads voltage by phi. So these are two different aspects, conditions based on which the angle, angle between the vectors of current and voltage would vary. One of them would lag and the other one would lead under the circumstances whenever tan phi is positive and whenever tan phi is negative. So these are the points that you will have to keep in mind. Okay, as far as the series LCR circuit is concerned. Okay, now this is an important aspect. So with this, we have covered the major part. Now we will see all the minor areas which are left. Okay, let me just check on the number. 7 and this has to be 8, isn't it? Let me just put 8 here. We'll go to the next concept, ninth concept. So the ninth one, we have something called as admittance. Okay, let me just write it. So we have something called admittance. Admittance is nothing but the reciprocal of impedance. So we call that as admittance. Very simple, nothing great here. So admittance is nothing but the reciprocal of impedance. So it is given by the letter Y. Okay, so where Y is nothing but 1 upon Z or 1 upon Z. Okay, and you know the unit, it will be ohm inverse. Because impedance is ohm, if you bring it up, it becomes ohm inverse. Okay, that's it, as simple as that. So this is the relation for admittance, wherein your admittance is the reciprocal of resistance. Impedance. Okay, the reciprocal of impedance, you call it admittance. Same way, the 10th one, you have something called as susceptance. I don't know if you guys have heard about this. Okay, susceptance. These are different parameters. Okay, again, the reciprocal of reactance, we call it as susceptance. Okay, so let me just write it there. So this is nothing but reciprocal of reactance. reactance is called susceptance. Simple, children. Is it clear? So the reciprocal of reactance, we call it susceptance. So susceptance can be of two different kinds. What are they? The first category is inductive susceptance. First one is inductive susceptance. Inductive susceptance is given by the letter S suffix L. So where S suffix L is equal to 1 upon XL, okay, which is 1 upon omega L. So this is your inductive susceptance. So let me just box it. So XL is 1 upon omega. So this is the value for inductive susceptance. All right. Simple. Again, the unit is going to be ohm inverse only. So the unit is same as your admittance, which is ohm inverse. Same way, the second category, second type of susceptance, I think most of you would have guessed it right, which is capacitive susceptance. So we have capacitive susceptance, which is given by S suffix C. Okay, it is the ratio of, the reciprocal of capacitive reactance. Okay, unlike there we had the reciprocal of inductive reactance, here we will have the reciprocal of capacitive reactance. So 1 upon XC. But then if you go and substitute the value of XC, as you guys are aware, XC is 1 upon omega C, right? So this will get reciprocal further and you will get omega C. Okay, so you will get the value as omega C. This is not K, it is C. So it's omega C. Okay, simple. So again, it is omega inverse only. That's the unit. The SI unit will remain same. So SC is nothing but omega C. So you can see here. All right. So these are the values. So again, the unit is ohm inverse. Simple. So this is all about the susceptance, which is the reciprocal of reactance. Two different kinds, inductive and capacitive susceptance. So each one of them we have seen the relations. Right? Now we are moving on to the next concept. So we have seen the small concepts here. Now moving on to the next one. Concept number 11. Resonance series LCR circuit. Okay. Resonance also we can call resonance in series LCR circuit. Now, what do you mean by resonance? Okay, what is resonance or what is the condition of resonance? That's very important for us to know. So, as far as the series LCR circuit is concerned, let's first draw it. So, you have an inductor, capacitor, and then you have a resistor. So, all three of them are connected across your AC voltage. So, we can call it V is equal to V naught sin omega. Okay, so I'm just putting an arrow mark to represent it in a simple manner. So when you have a series LCR circuit, the conditions for resonance, first let me tell you what is resonance. Resonance is basically a phenomenon where the frequency of the AC supply, okay, is equal to both your capacitive and inductive reactance. I repeat, resonance is a phenomenon wherein the capacitive and inductive reactance both would become equal to the source frequency. Okay, that is your supply voltage frequency. So that condition is called as resonance. Okay, so here the condition for resonance we will first apply. Let me just put it here. Okay, we will put it as condition for resonance. Condition for resonance is where your inductive reactance and capacitive reactance, both of them are equal to each other. So this is your condition. Now, having this condition in mind, when you go and substitute the values, we know that inductive reactance is given by omega L and capacitive reactance is given by 1 upon omega C. So you are technically equating both of them. So when you equate both of them, you will know that omega square is going to be equal to 1 upon LC. So what is omega in that case? This is square term. So therefore you will get omega is equal to under root 1 upon LC, which is 1 upon root LC. Okay, so this is the resonant frequency. This is the expression for resonant frequency. So expression for resonant frequency, we can write omega R, resonance, so I will use the letter R. So omega R is equal to 1 upon under root LC. So this expression is important as far as your resonance frequency is concerned. Okay. There is another expression also for the resonance frequency. It can be expressed in another manner. Okay. So we all know that omega is equal to 2 pi f. Okay. So what is f in that case? F is also frequency, no doubt. Okay. F is also a frequency. So when you try to express f in terms of the letter f, that is your linear frequency. So we can express f is equal to omega upon 2 pi. So this expression would become 1 upon 2 pi under root LC. Simple. Okay, because omega is 1 by root LC, but you have divided by 2 pi. So therefore you get f is equal to 1 upon 2 pi under root LC. So these are the two expressions for resonant frequency. So Fr is 1 upon 2 pi under root LC, and omega R, that is your angular resonance frequency, is 1 upon under root LC. So there are two formulas for resonant frequencies. The first one is linear resonant frequency. Okay, and the second one is angular resonant frequency. So there are two very different expressions that needs to be kept in mind. Okay, so there are two different aspects to resonant frequency. Okay, so that is all about the conditions, the resonance in series LCR circuit. So now we have seen the relations for them as well. Okay, this is the conditions. So next, moving on to the next one, the 12th concept for the day. So we have something called as quality factor. Next we have quality factor. So quality factor is given by the letter Q. Okay, as the name suggests. So quality factor is basically, I'll tell you what it is in simple terms. Okay, it is the measure of sharpness of the resonance. I'll write it here. It is the measure of sharpness of resonance. That is called as quality factor. Okay, and you can also call it as ratio of the reactance of the inductance and capacitance. Okay, so I'll just write down the expression for you for quality factor. So Q factor is also called as, so quality factor of Q factor is given by the ratio of XL upon R, which can also be written as omega R times L upon R. Okay, so these are the relations. So XL upon R, it can be written, or it can be written as XC also upon R. XL is omega L, right? That's the reason I have written it like this. The same way, Q can be written as XC upon R also. Okay, which is 1 upon omega R times C into R. So like this, you can express quality factor at resonance. So each one of them quality factor we are expressing. Okay, that is for the inductance, inductor separately, and for the capacitor separately. What about both of them together? Yes, that also can be done. So for both together, we can write it as 1 upon R times under root L upon C. It can be expressed like this also. Okay. How do we express like this? You can equate both of them, right? Here you can, if you equate 1 and 2, you can express both of them together in just one go. Okay, so we will get 1 upon R times root L upon C. So we can get this relationship. So this is the overall quality factor. So this expression for quality factor of series LCR circuits. So we can express it like this. So this is an important aspect. Now, then finally we have just one aspect. Okay, one or two aspects are left. With that we will wind up. Yeah, some more aspects are there. So next, what is the number? I guess this was 12. Okay, moving on to the next concept, 13th concept for the day. Next, we have something called as the relation between, say, quality factor, which is Q, comma, resonant frequency, which is omega R, and bandwidth. Okay, so three different terms are there. Now, what is the relation between these three terms? So you need to understand the relation is quality factor is equal to resonant frequency omega R upon bandwidth. Okay, upon bandwidth. Now, what is meant by bandwidth? Now, we have heard about this term in our daily lives. We all have a wireless, router at home, right? So, what is meant by the term bandwidth? Anybody can try? Have you heard about it? In general, what is bandwidth? It is not the internet speed. That is different. Don't tell me, sir, to 200 Mbps, 5 Mbps. That is bandwidth. That is different. That is your net speed. Internet speed is different. Bandwidth is totally different. Most often people get confused here. Okay. So bandwidth is basically, yeah, somebody wants to tell something. Please go ahead.
Coverage areas.
Yes, it is the amount of data that is transferred over a given area for a particular amount of time. That's correct. Your coverage. For example, if you have a bandwidth of say, 2 kilometers. So if you have your clients within the 2 kilometer range, so that person is able to use your service. Okay, so we call that as a bandwidth. So it is basically the maximum amount of data that can be transmitted over an internet connection. Okay, I'm talking with respect to internet over an internet connection in a particular amount of time. Okay, in general, if I'm talking, that is what would be bandwidth. Okay, so here we are talking about the span or the area also. Okay, that is absolutely right. Okay, now moving on. So this is all about your relation between quality factor, resonant frequency, and bandwidth. Okay, so with that we move on. So using this relation, we can find out any one for two of them is given, and they're asking you the third one. You can directly substitute here. You can. Okay, for that, this relation is really very useful. That's the reason I'm sharing this relation with you. Next, 14th one, moving on to the next concept. Next, we have something called as, the average power. Okay, so expression for average power is there. So we need to understand what is the expression for average power in a circuit. Okay, so let me write down average power. The expression for average power, it is represented as P average. So what is meant by average power? So average power is basically um, the power that is averaged over a full cycle of AC. Over one complete cycle, whatever is the power that is being used up is called your average power. We also refer it as true power sometimes. Okay, so it is expressed by the relation P average is equal to VRMS times IRMS into cos phi. This is the relationship. Okay, power can be expressed as the product of potential and current. Okay, V into I. So that is the general expression. Okay, I hope you guys are aware about how this relation came. Do you guys know that power is equal to the rate of doing work, right? Isn't it? So W by T. You guys remember that formula? right? So W can be written as, in terms of your electric field and charges chapter, we can express work done as V into Q. So V into Q by T. What is Q by T? The rate of flow of charge. We call it as current. So we can write T as V into I. This is how that relation came. Okay. So here V is nothing but VRMS and I is nothing but IRMS. Now here you don't have any term. Doesn't mean you don't have that angle. Obviously the angle is there. Okay. For which value usually cos is 1. You guys know, right? Cos 0 or cos 90? Cos 0, isn't it? So the value becomes 1. That's the reason there you don't have any term. But if you want to express the terms of phase angle, we will bring in the term cos phi. So that is the general expression for average power. I hope this is clear. So again, when you go and express in terms of, now IRMS we have written. Same way, if I want to express in terms of I naught and V naught, what will I do? Very simple. In terms of in VRMS, I will say it is V naught by root 2. For IRMS, I will say it is I naught by root 2. I hope you guys remember the formulas. Times cos phi, isn't it? Now what happens? Root 2 times root 2 becomes 2. You will get V naught times I naught divided by 2 into cos phi. This is another formula for average power. Simple, isn't it? So you have two different formulas for average power. First one is in terms of RMS voltage and current. Second one is in terms of peak voltage and peak current. So like this you can express the values of the values for average power. Okay, the expressions for average power. Now what is the unit of power? I hope you guys would be knowing this. The SI unit for power. What is it? The SI unit for power is watts, isn't it? Or watts, however you pronounce it, right? So it is watts. So that is the unit of power, the general unit. All right. So with this, we have now seen what is average power. Okay. So with that, we're moving ahead to the 15th concept, which is the power factor. Very, very important concept. So we are going to see what is the power factor. Now it's not something complicated, very simple. So, but you need to understand that it is the ratio of the power, the actual power or average power to the apparent power. Okay, so we will see it. So let me go and write it. So here power factor is nothing but cos phi. Same expression, children. You will go for a rearrangement. That's it. So we can express this as the value of true power or average power. True and average power both are same. Need not confuse between the two. On apparent power. Okay, so this is basically power factor. So this is how we express it. So when you go and substitute the values, we can say cos phi is equal to R upon Z, where R is resistance and Z or Z is nothing but your impedance. Okay, it's very simple. Whenever I say factor, power factor, it's just a number. Okay, so therefore it is dimensionless or it is unitless. It does not have any unit nor it has any dimension. Okay, now here there are different conditions for AC resistive circuits. I hope you guys know there is no phase angle. You know that phase angle is going to be 0 degrees. So this implies cos phi would be equal to, if I'm going to put 0 in the place of phi, cos 0, so you will get 1. You get unity, okay, for an AC resistive circuit. So different conditions would apply. Similarly, for AC inductive circuits. So AC inductive circuit or say capacitive circuit. Inductive or capacitive circuit, the phi would be equal to 90 degrees. Okay, or pi by 2 radians. So if you're going to go on substitute cos pi by 2, so in that case, you know that cos 90 is going to be equal to 0. So cos phi, or power factor, would be equal to 0 degrees for an AC inductive circuit. As simple as that. Same way for, say, for an RL circuit. For AC, RL circuit. What is RL circuit? Very again, nothing great, where you have resistance and inductor present together. Okay, so in this case, children, impedance formula would be equal to under root R square plus XL square. That's it. Okay, because only two different components are connected together. Okay, in series. So then cos phi would be equal to R upon Z. Simple. So this is how we express. Same way for, say, an RC circuit. If you take an RC circuit, that means you have a resistor and a capacitor connected together. In that case, your impedance, that is the overall effective resistance, would be equal to under root of R square plus XC the whole square. Simple. Again, cos phi is going to be equal to R upon Z only. Okay, so this is how you express for RC circuits. Same way for series LCR circuit. If you take a series LCR circuit, again, you know that impedance is given by the formula we just now discussed a few minutes ago, which is under root of R square plus XL minus XC the whole square. Okay, so we have this. So again, so cos phi is equal to R upon Z. Okay, using the same relation we will find out. Okay, this is for a general series LCR circuit. But when you take condition for resonance, what about for a resonance circuit? Things would be totally different there. Okay, at resonance, you know that what is the condition? At resonance, we all know that XL is going to be equal to XC. Both of them would be equal. Both of them would be equal. You know that the term, second term itself would go away. That wouldn't be into picture. So therefore, your impedance will be exactly equal to resistance. So then what do you think would happen to cos phi? So cos phi would be equal to perfectly 1. That means phi is equal to 0 degrees. Okay. So these are the conditions that you will have to know. For power factor, or for different cases we have seen. Starting from in the resistive circuit, then we have seen for the capacitive and inductive circuits, then combination of resistance and inductor, combination for resistance and capacitor, then combination of all three together. That is your inductor, capacitor, and resistor together. So like this, we have different combinations. All right. So that's all about the power factor, which is your 15th concept. Okay. Next, we'll move on to the 16th one, the 16th concept. Okay. So here we have something called as transformer. Okay. Again, this is also an important aspect. What is basically a transformer? We have heard about transformer in our daily lives. Even we would have come across one when we take a walk on the streets, right? So you would have come across a transformer. Can anybody tell me what is a transformer? Have you seen one in your lifetime?
Yes, sir.
Yes. Yeah. What is a transformer? According to you?
Direct current into alternate current, I guess.
Yes, it is a device which is used for converting the current. Correct, perfect. And we would have seen, these transformers play an important role in our daily lives. Okay, right from the transmission, happening from, say, the electricity board until the power is being until the current that is being transmitted to our households. So transformers, play a vital role for power transmission. Okay, so say you're generating electricity from a hydroelectric power plant. Okay, now hydroelectric power plant is being set up in potential areas where you have dams, right, or reservoirs which are at a certain height or at a certain altitude. You know that when the gates of the dams are opened, the water stored in the dam is having tremendous potential energy. Now where does this energy go once water is being released? This potential energy is getting converted to kinetic energy as the gates of the dams are opened. And it is going to make its way down. And you have something called as a turbine that is being set up, at a lower potential or say at a lower height. So once, the water is going to gush, across and then it is going to make contact with the turbine blades. The turbine blades, they start rotating. So the kinetic energy is getting converted to rotational, or you can say mechanical energy. That energy is going to get transformed to so what is called as electrical energy, right? So the electricity that is being generated at a hydro, electric power plant is pretty huge. Okay, it's not. We are not dealing with 5 or 6 volts. It can be a kilovolts or megavolts. Depends on the amount of electricity that is being generated. So our appliances at home we are using, it can be your television sets, it can be your laptop or your smartphones, your electrical devices such as microwave, or it can be your water heater, geysers, your toasters, induction stove, etc., etc. All of them would require electricity, but we can't use the electricity that is generated on the spot. You cannot use it just like that. Can anybody tell me why? Why can't you use 5,000, I mean, 5 lakh kilovolts or 5 megavolt of electricity to run your appliances? Can we use it real time? Yes. Can we use, children, 5 lakh voltage, or say 5 kilovolt, 5 megavolt of electricity to run your washing machine at home? Is it even possible? I mean, if it is possible, you tell me how it is possible.
It's not possible, sir.
Yeah, it's not possible. Why? That is because the devices that we are using, they have something called as a power rating. What does the power rating mean? They are designed to operate at a certain voltage. Something more or something less would result in the devices malfunctioning. That means they will not function as specified by the manufacturer. So we need to understand this. So every device has a design power rating. Okay, they are designed to operate in a particular operating voltage. So when I say operating voltage, you need to understand domestic household supply is having a particular voltage, which is designed for the devices to operate normally, okay, properly. Which is, anybody knows the domestic voltage that is being supplied to us by our electricity boards? Any guess?
220, sir.
Exactly, that's 220 volt. So the supply voltage to domestic households is 220 volts. So therefore, whatever appliance that you are using on a daily basis, they are designed to operate at 220 volts. Okay, in general. Suppose, say I am taking my laptop. Now my laptop does not require 220 volts. Suppose my laptop, is going to is designed at 110 volt, it will still work. Can anybody tell me why? Have you seen the laptop adapter? In there, they would have not written 220 volt. They would have written 110, but still it works. Why? Even though our supply is 220 volts, but when you connect a laptop charger
Has a
and you try to charge your laptop, it still works. Yeah, please, can you please, repeat what you just said?
because it has a regulator, sir.
Yes, there is some regulation going on, and most importantly, you have an adapter. Okay, inside the adapter, what you have is basically a small transformer which is there. Okay, that transformer job is to step down the voltage from 220 to 110 before it is being supplied to your laptop. Interesting, isn't it? So here comes the use of a transformer. The transformer is basically a device that is no doubt used to convert DC into AC, but still it can reduce the magnitude, okay, of a supplied voltage. Say your supplied voltage is huge, but you don't want that. You want something less. It can reduce it. So we call that as a step down transformer, which can step down the voltage as per our requirement. If our requirement is 5 volt, yes, it can still reduce it. If our requirement is more, say you are just supplying 220, but I want 440, is it even possible? Yes, it is. You have something called as a step up transformer, which can increase or enhance the voltage that is being supplied to it. So this is where transformers play a crucial role in our daily lives. Okay, so where step down transformers are used and where step up transformers are typically used. Okay, so step up transformers are typically used whenever you wanted to transmit current over large distances without considerable power loss. We would use a step up transformer. which can increase the voltage, and without power loss, you can transmit, the current over large distances. There we will use a step up transformer. Wherein coming down to a step down transformer, that will be used, that is used in our daily lives. Okay, wherever you have an electricity supply board, the supply comes, through high tension, cables, overhead cables, but it is being supplied to normal domestic households. We don't require, a huge voltage such as 5 megavolt. We only would require 220 volt. So therefore, it needs to be reduced. So there, a step down transformer is used at the substations or base station electricity boards, and from there it is being supplied to the retail outlets or domestic household supply. Okay, is it clear? So this is, the concept of what a transformer is all about. Okay, so now there is basically a simple diagram for a transformer, which you will have to keep in mind before even we jump into the actual concepts. So we will see that, okay, before we proceed any further. So I will draw the diagram of a transformer for you guys. Okay, so in general, transformer is, you can keep in mind, is basically a device that converts low alternating voltage to a high, or vice versa. Okay, low to high or high to low, both the ways that can be achieved. Okay, so I'll show you. You have something called as a primary coil. So we have a primary, coil. So this is connected to your AC voltage. So this coil, we will call it as primary. Okay, and we have another coil that is separated by a certain distance, okay, across the laminated core. I'm not drawing core here. Let me just draw that core also. There is something called as a core. Okay, this is the core, children. We call this as a transformer core, right? It is like this. Okay, and the other side you have another coil which is again wounded to this side. We call this as a secondary coil. Okay, let me mark it as S. Okay, so P stands for primary coil, and S stands for secondary coil. Okay, so these are the two different coils that are used in a transformer. The one is primary, the other one is secondary. Okay, so now moving on. When you have an alternating current in the primary, now there is something going to happen here. It is based on electromagnetic induction. Okay, so according to Faraday's electromagnetic induction, due to current flow in the primary, there is going to be an EMF that is going to be developed in the secondary. Okay, that is due to Faraday's law of electromagnetic induction. Now that EMF that is developed in the secondary depends on the ratio of the number of turns in both primary and secondary. Okay, so depending on that, you have an EMF that is being set up. So let me just write it here. So here across the secondary, you have a load. Load is something that is being connected. It can be your mobile, it can be your any day-to-day appliance that we are using. Okay, yeah, and between what is there, the square-shaped one, that is a laminated core. Okay, a laminated core, it is usually made up of iron. Okay, generally it's made up of iron. Okay, now here we have number of turns of the primary. Let me call the number of turns of the primary as, say, N1. Okay, or let me call it as NP. Okay, for simplicity. The number of turns in the secondary, I will call it as NS. Okay, and let me just write it here also for your understanding. So NP is the number of turns in primary, and NS is nothing but the number of turns in secondary. It is the number of turns in secondary. So these are the two different coils and their number of turns, both primary as well as secondary. Okay, so now we will see what are the relations that you will have to know. Okay, so voltage across primary and secondary is given by this relationship, children. So I'm just writing it here. Voltage across secondary to the ratio of voltage across primary is equal to the number of turns of secondary upon number of turns of primary. Okay, so like this we can express the ratio of voltages in terms of ratio of number of turns. So we can express it like this. Okay. Same way in terms of current, yes, you can still express, which is the current flowing through primary upon the current flowing through secondary. For current alone, the terms would get swapped. Okay. Otherwise, for number of turns in voltage, it is remaining intact. Okay. Now, here, NS by NP. This ratio is called as transformer ratio. Okay, it's called transformer or transformation ratio. Okay, this is an important aspect that needs to be kept in mind. Okay, so based on these values, if your number of turns of secondary is going to be greater than the number of turns of primary, okay, then you call this as a step up transformer. Okay, then the transformer is called step up transformer. So if for a step up transformer, this is the criteria. Okay, and what do you mean by step up transformer? Which increases the supply voltage.
Voltage increases, current decreases.
Yeah, so which will increase the supply voltage. Correct, that's right. Okay, so the supply voltage is going to get increased considerably. Okay, same way, if your ratio, I mean, if the value is going to be less, if I'm going to write the other way around, if I say NS is going to be less than NP, then the transformer is called a step down transformer. Okay, again, step down transformer is going to decrease the supply voltage. It will decrease the supply voltage. So these are certain important aspects as far as the transformer is being concerned. Okay. Last but not the least, we will end up with what is called the efficiency. Something is called, there is a term which is called as efficiency of the transformer. Can anybody tell me what is efficiency? What is meant by efficiency in the first place?
Output power divided by input power into 100%.
Yes. Efficiency means how efficient. If you are going to do a work, how efficient you are going to do the work. How efficient you are, trying to, give the concepts. Same way, when I talk about a transformer, if I say efficiency, I am talking with respect to its power. All right. The more powerful it is, I can say it is more efficient. But again, how will I compare the power? Based on what I am supplying and what I am getting. If my output is going to be more than the input, then I say it is more efficient. If my output is less than the input, then I would say it is less efficient. Okay, so that is basically the concept of efficiency. So here, when I say, let me just write it here. So efficiency, it is also given by a Greek symbol. Okay, so it is given by the symbol called eta. This is the symbol for efficiency. This is eta. It's a Greek symbol, ETA. Okay, so eta is nothing but the ratio of output power to that of the input power. So power output upon power input times 100. This will give you the efficiency of the transformer in terms of percentage. Okay, that's why I'm multiplying by 100. So you may not get confused why I'm putting 100 there. Okay, it is in terms of percent. That's why it's 100. Okay, this is all about the concepts for alternating current. So we have finished this entire chapter. The concepts I have discussed, each one of them in detail we have seen. Okay, so with this we finish transformer, and now we will move on. I mean, with this we finish alternating current, and we move on to the questions, one by one. Okay, I hope it's clear so far. The notes also I will share it. Okay, now we will start with the questions. Okay, one by one we will start the questions. So here comes the questions. I'll just give you the different types or different models of questions that can come from your exam point of view. Okay, so let me just write it here. So now we will see all the practice questions. Here comes the first question, children. So, we will move on to the question. First one. A transformer, a transformer, a transformer is having 2000, that is 2100 turns in primary, 2100 turns in primary, and 4200 turns in secondary. Okay, in secondary. Its supply voltage is 120 volts, 10 ampere AC. The secondary voltage and current are. Okay, so they are asking you what is the secondary voltage and current. I'm giving you the options. Option A, 240 volts, 5 amperes. Option B, 120 volt, 10 amperes. Option C, 240 volt and 10 amperes. And finally, option D, 120 volt and 20 amperes. This is the answer. Based on the question, try to identify what is given and then you can find out. You can go for calculation.
Option A, sir. 240 volts, 5 ampere.
240 volts and 5 amperes. Correct. So answer is option A. How did we solve this? Now, based on the given data, right? So we know that voltage across secondary to the ratio of voltage across primary is equal to Ns upon Np, isn't it? So using this relation, we can simply say Vs is equal to, go for substituting, 4200 upon, I think 2100 times 120. So you simplify this, you will get the answer as 240, right? So that is the voltage across secondary. Same way, you can also find out what is the current also across secondary. Go for a rearrangement. You remember the formula where I've given you all the three parameters. So Is is equal to, when you go for rearranging, you can write it as Np upon Ns into Ip. Substitute and simplify, you will get, again, same thing. Here you will write it as 2100, it's not 4200. So because it's the other way around, upon 4200 times 10. So which will give you the answer as 5 ampere. And hence the answer values are 120 volts and 5 amperes. That's the answer. So that's how you solve this question. And that's the reason the answer is option A. Fine. Pretty easy one. Moving on to the next question. The second question. So, okay. An AC source has voltage. An AC source has voltage and time variation in SI units given by the function let me just write it down here. V is equal to 120 sine 100 pi t times cos 100 pi t. Okay, this is the voltage function. Then the question is the maximum voltage and frequency the maximum voltage and frequency are? Okay, answers, and you need the options. Option A, 120 volts, comma 100 hertz. Option B, 100 upon root 2 hertz, 100 upon root 2 volts and 100 hertz. Option C, 60 volts and 200 hertz. And option D, 60 volt, comma 100 hertz. These are the options. Okay. So you are given with a voltage function. So using that voltage function, you will have to find out what is the maximum voltage and frequency. Yeah, proceed, go ahead, and you can give me the answers once you're done. Just try it. First, you will have to bring this to a general form. Once you bring it to the general form, it is easy to solve this question. Yeah, any answers? You're able to do this? A small, little maths you will have to apply. That's it. So people who are good at the trigonometric, ratios and simplifying half angle formula if you're using, you will get it. Anybody? Any guesses? How can we represent, children? 120 sine 100 pi t times cos 100 pi t. How can I write in terms of sine? There is a possibility we can write. Anybody knows how to write it? Use the trigonometric identity. The formula. There is one formula, no? Yes? Anybody try it? I can hear something, but you try to speak, children. That is better, instead of typing your comment. I'll have to go to that screen and then see. Yes. Feel
2
free to
sin
read.
A cos A, sir.
Okay. So V is equal to 120 sine 100 pi t times cos 100 pi t. What you said is right. So here I want to bring it in terms of a sine function. For that, what I have to do here? I am multiplying and dividing by 2. Okay, so 120 by 2 into 2. It does not make any difference. Are you understanding? I am multiplying and dividing by 2. So 2 sine, it is of the form omega t into cos omega t. Do you agree? Right? It is of this form. Now, 120 by 2 is 60. So 60 into, it is of the form 2 sine omega t to cos omega t. That is 2 sine x cos x. What is the formula for 2 sine x cos x? Anybody remembers?
Sin 2x, sir.
Sine 2x. Sure. It is sine 2x, right? 2 sine x cos x. That's correct. 2 sine theta cos theta. Sine 2 theta, right? That's correct. So you will write as sine 2x. Here in this case, sine 2 omega t over. So it is 60 into sine 2 omega t, which is 2 into 100, which is 200 pi t. Is it clear? Simple. So this is how we will express. Now we have brought it to the general form. Okay, it is of the form V is equal to V naught sine omega t. Right? So what is V naught here? We know V naught is going to be 60 volts. And what about your frequency? Your omega t. So omega is nothing but 200 pi. Okay, angular frequency I'm talking about. But here you can see the options are in terms of linear frequency. So what should I do? We know that linear frequency and angular frequency are related by f is equal to 2 pi by omega. You guys remember? right? Omega is to, so what is the relation? Omega is equal to 2 pi f. F is equal to omega by 2 pi, isn't it? So use that relationship. Let me just rearrange. I'm writing the other way around. So I'm substituting in the place of omega 2 pi f is equal to 200 pi. Okay, so pi would get cancelled. So f and 2 also you can cancel, right? 2 ones are 200. So f is equal to 100 hertz. So the frequency is 100 hertz and peak voltage is 60 volts. So what is the answer? The maximum voltage is 60 volts and frequency is 100 hertz. So the answer is option D, isn't it? D is the option. Okay, 60 volts and 200 hertz. 100 hertz. Okay, so the option D is the correct answer for this. Is it clear? I hope it's clear how to approach such questions. Okay.
Yes, sir.
So you will have to use a little bit of trigonometry and then do it. Okay, so trigonometric oriented approach. Next, moving on to the third different type of question. So we will come on, let's see it. So the next one, there's a different question altogether. It's a combination. It's a multidisciplinary question. Okay, two different chapters, three different chapters clubbed together, and then the question is being asked. Okay, so coming back, let me just write it here. Okay, the natural frequency of an LC circuit is 125,000 cycles per second. It is generally written as CPS. Okay, cycles per second. Then the capacitor is replaced. The capacitor is replaced with a dielectric medium K. Okay, the capacitor is being replaced with a dielectric medium K. Then frequency is found. To decrease. Frequency is found to decrease by 25 kilohertz. The value of K is. So you have to find out what is the value of K. Okay, that is the dielectric constant. Well, so I'm giving you the options. Option A, 3. Option B, 2.1. Option C, 1.56. Option D, 1.7. Yes, right? They're telling you that natural frequency of an LC circuit is 125,000 cycles per second. Then they are saying the capacitor is replaced with the dielectric medium K. When it is replaced, the frequency is found to decrease by 25 kilohertz. If all this is happening, they are asking you what is the value of K. So you have to predict what the value of K would be. So what formula can we use for an LC circuit? Frequency is given by the formula for an LC circuit as F is equal to, again you have to remember, 1 upon 2 pi under root LC. Okay, this is the frequency for an LC circuit. Now the question is, they are asking you what is going to be the value of K. Okay, so first, without inserting the dielectric medium, what is the relation? What is the corresponding relation is what we would like to find. Okay, so generally the natural frequency is 125,000. That's what they're given. So 125,000 hertz. That is the value. So that is equal to 1 upon 2 pi under root LC. This is one relationship. Okay, let us mark this as equation 1. This is first case. Second case, they are telling when they replace the capacitor, when capacitor is replaced, when C is replaced with dielectric, okay, with dielectric K, then what happens to the effective capacitance, children? My new capacitance will not be C anymore. C will be K times what it was before. It gets increased by K times. Okay, my new C, let me call it as C dash. New capacitance C dash will be K times the old capacitance. So using this relationship, so if this is happening, they're telling that frequency reduces by 25 kilohertz. Okay, so that means what is delta F? It is F minus F dash. So F is nothing but 1,25,000. F dash is 25 kilohertz. Kilo means you guys know it is 10 power 3, right? So how much is 125 into 10 power 3 minus 25 times 10 power 3? I think you can do an oral calculation here. 125 minus 25, 10 power 3 is common anyways. So I think you guys are getting 100 times 10 power 3, isn't it? Right? Which is 10 power 5. Okay, when you do the laws of indices. So this is basically your change in frequency. So this delta F is going to be equal to, again, our formula is 1 by 2 pi under root, not just LC, it is L K into C, because the capacitance gets enhanced by K times. Okay, this is the equation. Okay, so here we are having both the equations. You can divide the first equation with the second. Okay, dividing 1 by 2. So what happens when you divide 1 by 2? Let me do it. So delta F value I have found out as 10 power 5 is equal to 1 upon 2 pi under root L K into C. Okay, this is the second one. I have substituted. Okay, so dividing 1 by 2, what do we get? We are going to get 125. Okay, the first one was 125 into 10 power 3 upon 10 power 5 is equal to whole under root LKC upon LC. Into the 2 pi will get cancelled off anyways. Okay, here also you can see that CC is getting cancelled. Okay, I mean LL is also getting cancelled. So what are you getting here in this case? Okay, so 125 times here 10 power 3 and 5 also I will reduce it. Okay, so I'm reducing that also, which is 10 power 2 at the bottom, right? 3 goes, 2 is left, is equal to here under root K. So what is K? K is under root of 125 upon 100. What is 125 upon 100? You guys know how to extract the square terms, right? So extract all the square terms out. So what is the value that is left?
Square element, sir.
Pardon?
Sir, 120.
Sir, 5 into 25 divided by 10 into 10, sir.
சரி எவ்வளவு வருது டெசிமல்ல சொல்லுங்க. In terms of decimals, you will get this as 1.56.
Sir,
Yes. Tell me.
1.56 தான் சொல்ல வந்தேன்.
Yes, அதுதான் நானும் கேட்டேன். That's what I also asked. Okay, so it is 1.56. So appropriately, when you take it out and once you are going to simplify it, you will arrive at the value as 1.56.
Sir,
Okay. So this is how you go for the calculation. Okay. Any doubts, children? Here you can ask anywhere you felt it is you're not
yes,
able
sir.
to. Yeah.
Sir, root k equal to
Ah.
125 by 10 square இருக்குல்ல சார்?
Yes.
அது ரெண்டு சைடும் ஸ்கொயர் பண்ணாதானே சார் அந்த ஸ்கொயர் ரூட் போகும்?
ரெண்டு சைடுமே
ஸ்கொயர் தானே சார் பண்ணும்?
ஆமா
சார் அப்ப நீங்க வந்து 125 by
1 second under root நம்ம here we are having root, no? See, இங்க ஃபுல்லா we are having root, overall root நம்ம எடுத்திருக்கோம், correct? Okay. And k வந்து yes correct, நீங்க சொன்னது கரெக்ட் தான். So taking square on both the sides, you are coming that way, isn't it?
yes sir.
So if you take square on both sides, then that term, even then the value is going to be the same only, no?
Okay,
Even
sir.
if you are going to take square also, the value will be the same thing only. The value is not going to change considerably. Square also you're going to do, and you're going to find out 1.56 only you will get, right? You can do it like that also. Okay. Yeah. Fine. So that is it. Here I should have not put root. Correct. What you pointed is right. So I should have taken so squaring on both sides. Correct. So this we will take it off. Okay. Let me just this will be remain. Yeah, my bad. So here that root will not come. Okay. So here what we are doing, you can square on both sides as you rightly said. So if you are going to square, so here that term would go away. You will get the whole square. So even then the ratio is going to be the same. I mean the value that you would get finally is going to be 1.56. Okay, my bad. Okay, 1.56. So this is where you will get the corresponding value. That I should have not put. Fine. Thank you for correcting. All right. Is it clear? So this is how we do this, children. Okay. So with that, we have seen the different models for the day. Okay. So this you keep it in mind, the different approaches. So you have to understand what is given in the question. Based on the given data, we choose which formula would be a perfect fit. And then we are going to substitute, and then obviously you simplify, and then you do it. So here time plays a vital role. Time management, you'll have to manage your time in simplifying this one formulas by substituting the values. So that is where your prime time is being used. So if you manage it and if you are able to do it within the stipulated time, so you can finish maximum questions in a given amount of time. All right. So that is the strategy that you guys should start working on. First, concepts and formulas should be thorough. After that, your strategic approach in solving the numericals. Okay. So if this two is being taken care of, I'm very sure that you can crack the competitive exams, provided that you do maximum questions in a limited time, that too in a proper approach. You have to do it correctly. Okay, don't be overconfident also. Fine. So with this we will wind up today's session. Okay, so any doubts you can ask. All right.